I want y'all to ask why more often. Okay, here's some
Most people
sunglasses.
can't answer that question, or something like that.
But you should be able to. You should ask it. Light sensitive sunglasses. Y'all ever seen a sunglass turn dark when you go outside? Right?
Yeah.
They have silver and chlorine in them, chloride in them. Who's being oxidized in this case? Silver being oxidized. Silver starts off as plus and winds up as, what's the charge on silver on the right hand side? Doesn't have a charge, so that means it's zero. So it goes from being plus to being zero, so it is being reduced. It had to gain an electron. To go from +1 to 0, it has to get a negative something, right? To go from +1 to 0. So if the silver is being reduced, the chlorine must be oxidized. Okay? Now, we're going to skip this. I don't think we're ready for that. Why is this is methanol, also known as wood alcohol. It's not the kind of alcohol you want to drink. Bad for you. Why is it bad for you? Because methyl alcohol in your liver gets oxidized to formaldehyde, and then the formaldehyde gets oxidized to formic acid, and then the acid gets oxidized to carbon dioxide. Formaldehyde, formic acid, not very good for you. Formaldehyde, what do we do with formaldehyde? We preserve stuff. Formic acid, it digests stuff. We'll learn about formic acid later on when we talk about carboxylic acid. So don't drink methyl alcohol. No, methanol. Yeah. So, it's hard to tell where the electrons are going on there, right? This methyl alcohol is being oxidized to formaldehyde, and formaldehyde is oxidized to formic acid. Formic acid is oxidized to carbon dioxide, but I don't see electrons there. Do y'all see electrons? See charge? Hard to tell what's going on there, isn't it? But this is redox. There are some alternative ways you can look at organic molecules and talk about redox. And here they are. Oxidation always involves the loss of electrons, but for organic molecules, when you look at them, if you see that it's gaining oxygen or losing hydrogen, it is probably also being oxidized. Think about it. Gain oxygen, oxidize. Okay? Reduction. Lose oxygen or gain hydrogen. That's being reduced. Okay, so when you see organic molecules, it's a different way to look at oxidation reduction because you don't see charge there. It's not like looking at ionic compounds. Okay? There's just a couple of homework problems like that. Now, we're going to spend the rest of the class doing doing calculations. Yay! You not excited about that? I thought y'all missed calculations. You don't miss doing conversions?
No.
Who likes doing conversions?
We're doing them in math now.
What math do you 110? Who wants to be a nurse or a vet tech? Do you think you might have to do conversions?
Yes.
Definitely.
Every day.
All we're doing is changing the words. We're talking about chemistry. Y'all are going to talk about drops and milliliters and stuff like that. The same kind of stuff. If you could, I've had no fewer than 5 nursing students come to me this semester and say, "Thank you for teaching me how to do this." Because they have to do dosage calculations all the time. Okay? Same kind of thing that we're getting ready to do, okay? Let's look at this. Here's a reaction. Iron plus sulfur makes iron 3 sulfide. Okay? Now we're going to talk about this. And the mass of the reactants has to be equal to the mass of the products. Remember when we balanced equations and I said you have to have the same number of atoms on the left as you do on the right? Because you're not God. You can't create and destroy atoms. True?
Right.
Unless, well, wait a minute, let me check. Has anybody been promoted in the last couple of days and now you are a God? Because on Monday when I checked, nobody was a God. We're still all good. We're nobody's a God yet.
No,
Okay,
it's
good.
still
Okay. Not even, you probably gotta go through sainthood before you get to be a god, right? Yeah. Okay, so the mass on the reactant side has to be equal to the mass on the product side, the total mass, okay? So, that's the law of conservation of mass. You cannot create or destroy mass. The mass of the products is always equal to the sum of the masses of the reactants. So if I add up all the products, it has to equal to all the reactants. Now, like, when you go down to the fire pit, you burn a log, and you say, well, all I got left is these few ashes. What happened?
It was burned
Where did it go?
in the air.
The products of combustion reaction are what?
Gas.
CO2, gas, and water. Yeah, gas is water, right? So most of that mass went up into the air, right? You can't measure it. Well, you could measure it, but you're not worried about that when you're at the fire pit, right? Only I think about stuff like that when I'm at the fire pit. Okay. So, here's another example. Silver plus sulfur makes silver sulfide. It takes 2 silver atoms for every 1 sulfur atom to make 1 silver sulfide. How do I know it takes 2 silver atoms for 1 sulfur atom?
Just that.
Why?
Does the charge?
Because you need to balance it, right?
Because the balance equation tells me that, doesn't it?
Yeah.
The balance equation says it takes 2 silvers for every 1 sulfur, and I get 1 unit of silver sulfide back at the end. That's what the balance equation tells me.
That's a combination.
Do it?
And a combination.
Yeah, it's a combination reaction. Very good. There's lots of different ways you can look at that reaction. The 2 ways that we will talk about it are this way and this way. That reaction could be read as 2 atoms of silver react with 1 atom of sulfur to make 1 unit of silver sulfide. Or 2 moles of silver react with 1 mole of sulfur to make 1 mole of silver sulfide. Okay, if it takes 2 moles of silver to react with 1 mole of sulfur, that's kind of like saying 2 moles of silver equals 1 mole of sulfur. True? Well, if 2 moles of silver equals 1 mole of sulfur, what do you think we're going to do with that? We have an equality, what do we do with it? We turn it into conversion factors, don't we? Yay! So, here's our iron reaction again. 2 moles of iron react with 3 moles of sulfur to make 1 mole of silver of iron sulfide, iron 3 sulfide. So 2 moles of iron equals 3 moles of sulfur. 2 moles of iron also equals 1 mole of iron 3 sulfide. 3 moles of sulfur only equals 1 mole of iron 3 sulfide. So we can write all of these conversion factors from those relationships. Where do these coefficients come from? Where do those mole-to-mole ratios come from? Where does coefficients come from?
They're in your equation.
They come from the balanced equation. Okay? Equation must be balanced. And then you can write all of these conversions here. Okay?
Well, if it's not balanced, how do we know what the balance should be?
Well, then you have to balance it. You can't write these conversions if it's not balanced. You have to balance it first. Okay? So you should always check it, make sure it's balanced before you try this.
Right, but how do we know what the balance should be if it's not already?
I'm not sure I understand the question. Oh, well, then that's
We
a problem.
just assume they're balanced. We
No, I
have to check
wouldn't.
everything.
I would check it, make sure it's balanced. If you don't know how balanced equations, gotta go back and look it up. Come see me. We spent a whole class on Monday balancing equations, didn't we?
Mm-hmm.
Pretty much. Probably ain't got time to do that again today. Come see me. 6:30 tomorrow morning. I'll be there.
I gotta walk my dog.
Does she just say her
She just
dog
said
is more
that.
important than me?
He's been stinking for a month.
Oh,
He's a
God.
mess.
You better handle that now.
All right. What mole factor would we use to relate hydrogen and nitrogen from that equation up top? Look at it. We're going to vote in just a second. Look at question A and tell me what the right answer is. Is it 1, 2, or 3?